Hello everyone, welcome to chemistry classes. So in the previous class we have discussed about some problems on equilibrium constant and Gibbs free energy as well as on cell potential. Okay, so now we are moving towards further important bit of this topic is conductance of electrolytic cell. The conductance of electrolytic cell. So I think all of you remember about electrolytic cell. In electrochemistry part 3 I have explained about electrolytic cell. So what do you mean by electrolytic cell? So here I will use this space, electrolytic cell. So I will take a beaker or I will take a container. In that the two electrodes are dipped and these two electrodes are connected with the external circuit which carries a cell. So here, and here I'll put some electrolytic solution. Okay, so this is my electrolytic cell. This is negative, this is positive terminal. So this is negative electrode, this is positive electrode, and here I have taken electrolytic solution. So in electrolytic cell what happens? Electrolytic cell. So electrolytic cell is a device which converts electrical energy into chemical energy. So in this cell the process taking place is called as electrolysis, isn't it? So we are aware about that electrolysis reaction. So in this electrolysis reaction, the electrolysis reaction depends upon the nature of electrolyte used. So if I change the electrolyte, if I change the concentration of electrolyte, my electrolysis process changes. So because of that reason, it is important to understand the nature of electrolyte. On changing the electrolytic solution, how my electrolytic process varies. Electrolysis varies. So because of that reason, I am going to study the conductance of electrolytic cell, isn't it? So to understand the conductance of electrolytic cell, so we have to understand some basic concepts. So those basic concepts are nothing but to understand conductance of electrolytic cell, I have to consider first resistance. So if I understand what is resistance, then it is easy to understand conductance. Okay, so resistance, what is the resistance? So if I consider this is my electric wire, so if I pass electric current through this, electric current passes, and this wire has got, by virtue it has got some amount of opposition to the flow of electric current. So if this conductor is added with some electric terminals, electric plates, so if I try to pass the charges from this end to this end, on going from this in going through the body of this conductor, those charges experience some opposition. That opposition offered by the virtue of by the body of this conductor is called as resistance. So resistance is opposition to the flow of electric current. So if electric charge is passing in this way, so there are some components which resist the flow of that electric current. So that opposition is called as what? Resistance. Okay, so ಯಾವುದೋ ಒಂದು ನಾವು ಕಂಡಕ್ಟರ್ ಅನ್ನು ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ ಅದರ ನಾವು ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್ ಮಾಡಿದಾಗ, ಸೊ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್ ಆಗೋದ್ರೆ ಏನು? ಪ್ಯಾಸೇಜ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಸೊ ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಪಾಸ್ ಆಗುವಾಗ ಈ ಕಂಡಕ್ಟರ್ ಒಳಗೆ ಇರುವಂತ ಒಂದಿಷ್ಟು ಮಟೀರಿಯಲ್ ಏನ್ ಮಾಡ್ತಾವ ಅಂತಂದ್ರ ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅನ್ನ ಪಾಸ್ ಹಾಕ್ಬಿಡೋದಿಲ್ಲ, ಅದನ್ನ ಏನ್ ಮಾಡ್ತಾವು? ಅಪೋಸ್ ಮಾಡ್ತಾವ. ಸೊ ದಟ್ ಅಪೋಸಿಷನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಆ ಅಪೋಸಿಷನ್ ಏನ್ ಕರಿತೀವಿ ನಾವು? ರೆಸಿಸ್ಟೆನ್ಸ್. ಸೊ ಇಟ್ ಈಸ್ ಸಿಂಬಲೈಸ್ಡ್ ಬೈ R. This resistance is directly proportional to the length of the conductor, length of the electric wire. Say if I consider this is my conductor, so the resistance is directly proportional to L, length of the conductor. So as the length increases, resistance also increases. So this has got some resistance, this has got more resistance. Now the length is increased, and it is inversely proportional to area of cross section. Area of cross section means what? This is my conductor. So if I cut this conductor like this, so this is called as area of cross section. Area of cross section. As area of cross section increases, resistance also sorry, area of cross section increases, resistance decreases, because it is inversely proportional. Inversely proportional. So resistance is directly proportional to length of the conductor, and resistance is inversely proportional to area of cross section of the conductor. And one thing here, this is about the solid conductors, so we can use length and area for the solid conductor, and we are considering electrolytic solution. Now what we have to study? The conductance in electrolytic cell. In electrolytic cell we use solutions. So in that case we consider L is equals to the length of separation between the electrodes. If I put the electrode in the electrolytic cell, there is a distance between the two electrodes. That distance is called as L, and A is the area of electrode. A is nothing but area of our electrode. So now R is equals to, so mathematically we can write, we can simplify this. R is equals to rho into L by A. Rho into L divided by A. So where rho is called as specific resistance, it is called as specific resistance, or it is also called as resistivity. It is called as specific resistance or resistivity. So according to IPC convention, resistivity is more preferred than specific resistance. So it is better to use resistivity than specific resistance. So I use resistivity. So rho is resistivity, L is length of the distance between the electrodes, and A is the area of cross section of area of the electrodes. So now what is the unit of R? Unit of R is equals to, unit of resistance is equals to ohm. This symbol indicates ohm. This is ohm. The resistance, unit of resistance is ohm. The SI base unit is kg meter square per cubic Simon square amperes. Cubic Simon square ampere. So this is the SI base unit. About this you are aware in your physics. Okay. And now come, so what is the exact meaning of this resistivity? We will understand what is resistivity. So resistivity, so I will simply change this formula for this resistivity. Resistivity is equals to A comes this side, so now it becomes resistance into area divided by L. Resistivity is equals to resistance into area divided by L. So this is resistivity. If length, area of the cross section is equals to 1 centimeter square. Area cross, if I consider I want to calculate resistivity of this material. So now I take area of cross section is equals to unity 1 centimeter square, and length is equals to 1 centimeter. Length is 1 centimeter and area is 1 centimeter square. Now what happens? So put these two values in this equation. Rho is equals to R into 1 centimeter square divided by 1 centimeter. So now 1 into 1, 1 only. 1 divided by 1, 1 only. So now rho is equals to R. So what is the meaning? What is the exact meaning of this equation? So here, resistivity of a conductor is nothing but it is the resistance of a conductor when area cross section is equals to 1 square centimeter and its length is equals to 1 centimeter. If the length of this conductor is 1 centimeter and area cross section is 1 square centimeter, then resistance of this material is called as its resistivity. Now we can call it as resistivity. So then what is the unit of resistivity? How to find the unit of resistivity? So let us fill the value. The unit of R is what? Ohm. Unit of area is what? Centimeter square, or we can use meter square. So it is the sub multiple of meter square. Okay. And length is centimeter. What remains here? Cancels out. So the unit of resistivity is ohm centimeter. The unit of resistivity is ohm centimeter. So please remember, sometimes we use unit of resistivity is ohm meter. Unit of resistivity is ohm meter or ohm centimeter. So this is resistivity, and how it is defined? Resistivity is defined as it is the resistance of a material when area cross section is equals to 1 square centimeter and length is equals to 1 centimeter. So next, now we can understand what is conductance. Now it is easy to understand what is conductance. If you understand resistance, now it becomes very much easy to understand conductance. So what is resistance? So resistance is nothing but opposition offered to the flow of electric current. Now the conductance, it is symbolized as G. Conductance is the ease of flow of current. If a material, how much easily it gives or it allows to electric current to pass through it, that easiness is called as conductance, or it is the capacity of a material to allow the electric current through it is called as conductance. ಒಂದು ವಸ್ತು ಎಷ್ಟು ಈಸಿಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅನ್ನು ಪಾಸ್ ಆಗಕ್ಕೆ ಬಿಡುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಏನು ಕರಿತೀವಿ ನಾವು ಕಂಡಕ್ಟನ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಹೌದಾ? ಸೊ ನಾವು this conductance is the reciprocal of resistance. So this is important. Conductance ಅಂದ್ರೆ ಏನು? Opposition offered to the flow of current. Current flow ಆಗೋದಕ್ಕೆ ಅಪೋಸಿಟ್ ಮಾಡೋದೇನು? resistance. ಆ current flow ಆಗೋಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡೋದೇನು? conductance, ಹೌದಾ? So now our conductance is the reciprocal of resistance. So now we can write G is equals to 1 divided by R. ಏನು ಬರೆಯಬಹುದು ನಾವು ಇದನ್ನ? G is equals to, G means what? Conductance is equals to 1 divided by resistance. So it is reciprocal. So now what is the unit of conductance? Now how to write unit? Say what is the unit of resistance? 1 divided by ohm. So we can write per ohm. Per ohm is called as, is the unit of resistance, unit of conductance. You can write as per ohm, or you can write it as mho. Reverse. OHM means ohm, MHO means mho. Mho is also unit of conductance. Or you can also use one more unit, Simon. You can use Simon as a unit of conductance. So please remember the unit of conductance are per ohm, mho or Simon. And now, so G is equals to 1 divided by R. What is R? R is equals to what? Rho into L by A. Let us write them. G is equals to 1 divided by R. R means resistance. So I will write, I will put the value of R. So what is R? R is equals to what? R is equals to rho into L divided by A. Now just I will write rho into L by A. Here I have written rho into L by A. So simply I have divided 1 by rho into 1 divided by L by A. So now it becomes 1 by rho into A by L. Denominator of denominator goes to numerator. But this is also important. So it further it becomes L by A. It is also very important component. 1 divided by rho, 1 divided by L by A. Now it becomes 1 divided by rho into A by L. So G is equals to, now this 1 divided by rho is called as one more important term, that is none other than, now rho is specific resistance, now it is specific conductance. See here, as 1 by R is conductance, now 1 by rho is specific conductance. Specific conductance. Now this specific conductance is called by another name, that is conductivity. As specific resistance is known as resistivity, now specific conductance is known as conductivity. So according to IUPAC convention, it is more important to use the word conductivity rather than specific conductance. We have to use conductivity. It is symbolized by the letter kapha. It is not K, it is a Greek alphabet kapha. Okay. Not kapha, it's kapha. Now, so kapha is equals to what? 1 divided by rho. 1 divided by rho. What is rho? See here, the formula of rho is equals to R into A by L. Let us write here. Kapha is equals to 1 divided by R into A divided by L. Now, L divided by R into A. You can write like this, L divided by R into A. Now let us write unit for this. What may be the unit? What is the unit of length? Centimeter or meter. Unit of or ohm. Unit of area is centimeter square. Centimeter square. Now centimeter and the square cancels out. What remains? 1 divided by ohm centimeter. Now it becomes per ohm per centimeter. So the unit of kapha is per ohm per centimeter. It is a sub multiple of per ohm per meter, per ohm per centimeter, per ohm per meter. So we know that per ohm is nothing but Simon. So Simon per centimeter. It is nothing but Simon per centimeter. Per ohm is nothing but Simon. Here we have used per ohm is nothing but Simon. So now it becomes Simon per centimeter. So please remember, the unit of kapha is Simon per centimeter or per ohm per centimeter or per ohm per meter. The next, so as already I told, L by A is also an important component. So that L by A is called as cell constant. That L by A is called as cell constant. It is very important. So by this, by calculating the value of L by A, so we can understand the other parameters of the electrolytic cell. So cell constant is given as G star. The symbol of cell constant is G star. G star is equals to L by A. Simply it is constant. L is constant, A is constant. So G star is equals to L by A. So now consider this equation. G is equals to 1 divided by R. 1 divided by rho into 1 divided by L by A. So in the place of L by A I will put G star. So here 1 by rho means what? 1 divided by rho means what? 1 by rho is kapha. I will write directly kapha into 1 divided by L by A. L by A is nothing but my G star. Kapha into 1 divided by G star. So G is equals to kapha into 1 divided by G star. If G star comes this side, what happens? Kapha is equals to G into G star. Kapha is equals to what? G into G star. So what does this indicate? Conductivity of a cell is equals to conductance of a cell multiplied with its cell constant. So by using this equation you can solve the numerical problems, isn't it? So these are the parameters of the electrolytic cell. And one more important thing, as we have defined resistivity and also we have to define conductivity. Let us define conductivity. So I will remove this part. So now once again I will write here, what is my conductivity? Kapha is equals to, conductivity kapha is equals to 1 divided by rho. 1 divided by rho. And also, and rho is equals to what? And directly I will write this thing. Kapha is equals to L divided by R into A. R, you can write kapha is equals to 1 by R means what? 1 by R is G. G into L by A. Kapha is equals to G into L by A. L by A is nothing but what? L by A is my G star. So you can write kapha is equals to G into G star. So by using any one of this, I should give the definition of kapha. Okay. So I'll take this one. See here, let us take, if length is equals to 1 centimeter and area is equals to 1 square centimeter. Length is equals to 1 centimeter, area is equals to 1 square centimeter. This is for solid. Length and area is there for solid. If I take volume, for solution we have to consider volume. Volume is equals to what? Area into length. Area into length is nothing but volume. Volume is equals to what happens here? 1 centimeter into 1 square centimeter is equals to 1 cubic centimeter. 1 cubic centimeter. So 1 cubic centimeter is can also be written as cc. Cc means what? Cubic centimeter. So it is also equals to 1 cc is equals to 1 ml. 1 cc is equals to 1 ml. Now we can write. Also from this you can write, see here, the specific conductivity or the specific conductance or conductivity of a cell is nothing but the conductivity of a cell is the kapha is equals to Z. Conductivity of the cell is the conductance of the cell of 1 ml solution. conductance of 1 ml solution is called as conductivity. So it is defined as the conductance of 1 ml of electrolyte. So conductivity is nothing but it is the conductance of 1 ml of electrolyte. 1 ml means what? In 1 cc area 1 ml of electrolyte is present. So conductance of 1 ml of the solution is 1 ml of the electrolyte is called as conductivity. The conductance of 1 ml of solution is called as conductivity. Please remember, this is also important. So 1 cubic centimeter, how we can write it as? So you can consider a cube like this. See here, further more deeply you can understand. If I take the electrolytic cell, so this is the solution in the electrolytic cell. The conductivity is given as, see here, I will consider 1 cubic centimeter area or 1 cubic centimeter volume of 1 cubic centimeter. So the conductance offered by the solution present in this area is called as conductivity, simply. So this is 1 cc volume or 1 ml volume of 1 ml of the solution. The conductivity or conductance given by or conductance offered by the solution present in this area is called as conductivity or specific conductance. Okay, so this is about the very much basics of conductance of electrolytic cell, and subsequent classes or subsequent videos we are going more deep into this. Okay, so if you find this video is helpful, please like, comment and share among your friends, and don't forget to subscribe. Thank you so much for watching.